Question, which lead code 215, kth largest element in an array. The question says, given an integer array nums and the integer k, return the kth largest element in the array. It's basically asking about the kth largest, like if k equal to 1, then we have to return the first largest or second largest or third largest and so on. So let's take example 3, 2, 1, 5 and 5, 6 and 4. Okay, and the value of k is 2. So we have to return the second largest element in this array. So since we can see that the first largest means the largest element is 6 and the second largest is 5, so we are returning 5. It's basically a simple question if we are using the sorting algorithm. Okay, so first clear the screen. Now if we are taking that example 3, 4, 5, 7, 1, 2 and 8, and if k equal to 2, so this is our array. So we know the second largest element is here is first largest equal to 8, second is 7, so we are returning 7. Okay, so the first step to solve this question is first sort the array. So on sorting 5, 1, 2, 3, 4, 5, 7 and 8, this is the array. Okay, and if k equal to 2, then array of n minus k. So we can see that the array of n minus k is our answer. If we sort the array and after sorting the second largest element is on this position, so we can directly use the indexes and return the respective answer. Okay, so but this is not the what interviewer demands. This approach is operates in n log n complexity. We have to find a new optimal approach. So in the optimal approach we can use heap data structure. How we can use, so let's see. If this is our array 3, 5, 7, 1, 8 and 2, okay, and if k equal to 2, then we can form a min heap. Okay, min heap means a priority queue. Okay, min heap, this is a min heap. Here the root element is always greater than child, always smaller than child, my mistake. Root is always smaller than child here, and in this case we start insert first k elements in min heap. Okay, so the first is 3, then 5, then 7. We care that take the k equal to 3. Okay, take the k equal to 3, so you will understand properly. 37. Okay, so you know it is a heap as the child element is 3 and as the parent element is 3 and child are 5 and 7, and the parent is always less than child. Okay, so this is a heap which is min heap. And now what we can do, we are having these elements remaining. So if we want the largest element, so we can ignore the elements which are smaller than this. Okay, because it is the smallest element till now. So if we are adding 1, so this can't be a largest element, so we are ignoring the smallest element and adding the largest element than the root node. Okay, so let's see. We are adding 1. If we are adding 1, it is not good, because if we are adding 1, so it will become 1. And one thing we also have to make the size same, like its size is k, so it will remain k every time. Okay, so if we add 1, but 1 will not be added, but let's try by adding 1. If we add 1, so 1 will here, and we have to also pop the element, so we will pop 3. Okay, we will pop 3 in the in the min heap. In min heap, the when we pop the element, the minimum element pop. So 3 is the minimum element here, so 3 will be popped. Okay, so 1 and 5 and 7, this will be our, this is our wrong answer. Okay, because 3 can be a third largest element, but 1 cannot be a third largest element, so it contradicts our case, so it is wrong. Okay. So make the condition that we have to add elements which are greater, which are greater than the root node. Okay, so take this condition and solve further. Okay, and after the first, and we have to pop elements also. Okay, but at the last, when the last element is added, when the 2 will be added, okay, when the 2 will be added, what will happen? The 2 will here, and 5 and 7, no, this is not. And so let's drive in first. We are seeing our array 357 182, 357 182, 357 182. Okay, the first step is to make a mini heap. Okay, so we are making a mini heap and add first three elements, so 3 5 and 7. Okay, so now we will pop the element from this. After, on popping the element, we will have to remove the minimum element which is at top. So after popping, it will become 5 and 7. Okay, now we have to add next element is, and since the next element is smaller than the top element, next element is smaller, 1 is smaller than 5, so we will not add 1. Now move to 8, so we are adding 8. Okay, so add 8 5 7 and 8. Okay, now, okay, so we have to see that the next element is 2. Okay, the next element is 2, which is smaller, since 2 is smaller than 5. Okay, so we will not add 2. Okay, so this will be our priority queue, and you can see that the top of this priority queue is our minimum element. Okay, so the minimum, sorry, minimum element, no minimum element, the top of this, you have to, we can see that the top of this priority queue is the our required answer. Okay, kth largest element is equal to 5 here. Okay, and in our answer, if we can find the first largest is, this, the second is this, and third is this, and in this we can also find the top element is the largest. So we have to first create a mini. Okay, we are creating a mini, so okay, we are having mini. Now add first k elements. Now add first k elements in this heap. Okay, now we have to add the remaining elements which are greater than, which are greater than the parent node. Parent node is top. Okay, for we will start this from I equal to k is less than plot size I plus plus. Okay, and we will put a condition if the nums of I is greater than pp dot top, then only we have to add this. First we have to pop, then we will add. Okay, so this is it, and at the last we will return the top element of the priority queue. So let's run this. So it's accepted, and now we have to submit this. So it's also submitted, and this is our logic, and it is the most optimal approach of this. So kindly press the like button, and you can share.